All right, hello again. This is Jeff Scott of Blackhawk Technical College. I've been going over the first 17 chapters of our book, iOS 9 App Development Essentials for the 152, 153 mobile web development iOS class for the spring 2016 semester at Blackhawk Technical College. What I'm going to do right now is come in here to Xcode and create yet another file or another playground page. It doesn't seem to want to let me do that, so something's going on here. If that was it or not. That was it. So I'm going to create a new playground page here, and I'm going to call it Flow Control Examples. Flow Control Examples. And I'm going to base it basically off of what's in the book starting on page 61. All right, the first thing they talk about in there is a for loop, and you all know how to use a for loop. In other words, if I come through here and say this, for, remember I no longer need the parens here. For LCV equals 0, LCV less than or equal to 10, LCV plus plus. Okay, now I'm going to come in here, and in there I'm going to say print LCV. All right, so it doesn't seem like something. Let's see what it doesn't like. Use of unresolved identifier LCV. I need the word var in front of that. That's what it is. For var, LCV equals 0, LCV less than or equal to 10. So now what doesn't it like? I think it's this plus plus because for some reason I got a blank space there. Okay, there we go. And if we look someplace, there it is down at the bottom of the screen. There's the number 0 to 10. If I wanted it 1, of course, all I'd have to do would be to change that to a 1. And now I should have the numbers from 1 to 10 printed on the bottom of the screen, and you can see them. All right, so the only thing that really changes here between our for loop that we had in Java and in C and in other languages, as opposed to the for loop we have right here, is the fact that we don't have to put that into our condition into curly braces. Other than that, there really isn't any difference. There also is a shortcut here where I can say for var index in 1 10 print index. And what you should notice after we do that, again, I get the numbers 1 through 10 printed. Now this is going to keep printing and it's going to be ugly and ugly, so I'm just going to grab this stuff that I've just done in here and I'm going to comment it out. So as I go through here and I do something, whoops, I will comment it out. Okay, so now I should be back in just a second to just the 1 to 10. Okay, there it is. Now you'll notice right there I've got dot, which means print everything within the range of 1 to 10. What if I leave one of those dots out? Well, I get an error message, but if I say 1 less than 10, now what should print in here are the numbers 1 through 9. All right. So let's comment this out. And let's come down and do a while loop. Okay. So var LCV equals 1 while LCV less than or equal to 10, print LCV. Should look familiar to you, and so should the results right here when they come in just a second. Whoa, I didn't change the result. So let's go in there and say LCV plus plus. I better do that. I'm in an infinite loop. How about that? LCV plus plus. And there it is. Well, you got to see what an infinite loop looked like anyway. All right. So that's the while loop. Again, looks very similar to what we've been using. All right. Now, there is no do while loop in here. The do while loop has been replaced with a repeat until loop. So let's comment all this out again. And we'll again say var LCV equals 1, repeat, print LCV, but down on the bottom here we want to say until, I'm sorry, it's repeat while, not a repeat until. Repeat while, and what we want to do is we want to repeat that while, I think we do need a parens around this. LCV less than or equal to 10. We'll try to remove the parens in a second. And look what we have. We still have the same infinite loop because we didn't come in here and say LCV plus plus, which is what I should have done. All right, now that I've changed it, notice that it's okay again. Let's try it. Let's try to remove the parens here and see if it takes it without the parens. And it does. Okay. So what you've just seen here, I've duplicated the code that's on pages 61, 62, and 63 in your book with my own examples. All right, but what you see here is that we're writing loops. Okay, so we've seen the for loop, the for in, the while, and the repeat while. Okay? All right. These shouldn't be anything new, but since I don't really like the repeat while, so I'm going to comment that out. And I'm going to come down to the bottom and comment that out. But I'm going to take our while loop that we had here and I'm going to uncomment it. All right? In other words, I'm just going to remove the comments from here and from here. Okay, so we've got our while again. You will see all that stuff. Okay? All right. So I'm going to come down here and I'm going to put it while it's less than or equal to 10, I'm going to do this. I'm going to say here, if, and I remember I don't need the parens, LCV equal 7, break. Now let's see what we get. Notice that what we get for our answer is 1, 2, 3, 4, 5, 6, because once it equals 7, it says break out of the loop. So when we do a break, you can see exactly what happens. If we replace the word break with the word continue, what I should get then is 1, 2, 3, 4, 5, 6, 8, 9, 10, and it should skip printing out 7. All right, so it stopped on 6 with just the word continue. Oh, because it never incremented itself there. All right, because it skipped that. So let's see, how do we fix that? Let's set this equal to 0. And let's do the LCV plus plus right at the beginning here. All right. Now notice that it actually goes down and it prints 11, but that's okay. But let's just take a look here. So while it's less than or equal to 10, so let's set it equal to 1 to begin with. All right. So, no, leave it at 0. Because the first thing that we're doing here is we are adding 1 to it right there. So we're always going to add 1 to it. So while it's less than or equal to 10, so let's just play computer. The first time through it comes through 0 is less than or equal to 10. So it adds 1, making it 1. It's not equal to 7, so it prints out 1. Prints out 2, prints out 3, prints out 4, prints out 5, prints out 6. Then it adds 1 to it. And is it equal to 7? Yes, it is. So it doesn't print out 7. Goes back up to the top, does 8, does 9. All right. Now, the way that we've written this, we don't want to say less than or equal to 10. We want to say less than 10. Now we get the numbers 1, 2, 3, 4, 5, 6, 8, 9, 10. Now, if that doesn't make sense to you, go back and take a look at it. Key this stuff in yourselves. This is, this is the best way possible for you to learn any of this. All right. Now, I'm going to hit enter quite a few times here to move this stuff up. In fact, let's see. I don't want to do that yet. I want to comment this stuff out that I've been working on. All right, now I'm going to come back up here. All right, let's just do a couple real simple things here. We've already done some of this, but we'll do this. Var x equal 15, var y equal 10. If x greater than, we'll say less than or equal to y, remember we don't need the parens, I'm going to have to stop doing that. If x less than or equal to y, print x is less than or equal to y. And I don't really like the way that reads. So remember, I don't have to print that. I can print this. There. So in that case, what that would print out, and it's not true, but if it was, it would print out 15 is less than or equal to 10. All right. There is an if that does not have any kind of else with it. You know as well as I do if I come down here and I say else, print, and let's just grab all this code that we've got right here. We'll modify it a little bit. Is greater than y. Okay? And what do we get? It prints out 15 is greater than 10. So you very quickly saw how to use an if and how to use an if-else. So we could change this, okay, and have it say if x is less than y, we could say that it's less than, and that's fine. All right, and then we could say here else if x equal y, and then we could say x is equal to y. And finally, we can have another else down here. Where we say print and you notice that's the one that will print. Okay? But that's an example of, as in all other languages, if we can have as many else ifs in here as we want to, and we can have a closing if to grab everything on the end if we want to. All right, remember the way that this is set up right now, if this first if is true, we skip these. If the first if is false but the second if is true, we skip this. Only if the first if is false and the else if is false do we go down and do the else. All right, so if we reverse, let's say, we'll make that 100. So it should say 15 is less than 100, and it does, and it skips these two. If we made them both 15, it now skips this one and says 15 is equal to 15, and it skips that one. And if we go back to what we had originally, it skips the if and the else if, and it does the else. All right, the last thing that's shown in this chapter, and this is new, it's called the guard statement. And they mention the guard statement is a Swift language feature introduced as part of Swift 2, so you can see how new it is. A guard statement contains a Boolean expression which must evaluate to true in order for the code located after the guard to be executed. The guard must include an else clause to be executed in the event that the expression evaluates to false. The code in the else clause must contain a statement to exit the current code flow. Either a return, a break, a continue, or a throw. Alternatively, the else block may call any other function or method that does not itself return. All right, so I'm going to put in the example that they show on page 67 in the book. So again, I'm going to comment all this stuff out that I've done thus far. All right, move myself up a ways here. And again, this is the example that they show in the book. So this is a function, so func, multiply by 10, value int. Again, this is all taken right out of the book on page 67. Guard. Notice it's picked up because it's a key word. Let number equal value where value is less than 10. Else, this is screwy. I've never seen this stuff either. Print number is too high. Return. And that should be there. All right, now we've got to say let result equal number times 10, not number, number times 10, print result. All right. We've never set up a value for number. They don't show it in here, but let's try that. Let's see if that fixes the errors that we've got. Var number equal 1. See if that removes all the errors that we had, and it does. All right, so I'm getting a warning right here that says immutable value number was never used. Consider replacing or removing it. And the reason for that is we just want the word number, not the variable number. That should fix it. Let's just change it to too high. Guard let number equal value which is what we passed in. Let result, I don't think we need this. Use of unresolved identifier number. Func, because I'm going to have to look at this myself if I plan on teaching it to you. Func multiply by 10, value, colon, int, question mark. Guard, let number equal value where value less than 10, else print number is too high. Says use unresolved. Let's put number in there. See, we're setting number in here though, so I don't understand why I would be getting that error. Use of unresolved identifier number. So it's saying right here it doesn't understand what number is. Ah, it's because this ending one that's right here has to come in here. There we go. So let's see. It says the function takes as a parameter an integer value in the form of an optional. So that's our parameter right there. We'll talk about optionals, but not right now. The guard statement uses optional binding to unwrap the value and verify that it's less than 10. In the event that the variable could not be unwrapped or its value is greater than 9, the else clause is triggered. The error message is printed, and the return statement is executed to exit the function. In the event that the optional contains a value less than 10, the code after the guard executes to multiply the value by 10 and print the result. A particularly important point to note about the above example is that the unwrapped number is available to the code outside of the guard statement. This would not have been the case if the variable had been unwrapped using an if statement. So I guess the bottom line is this. Notice what we have in here. That number that's right there is really being set right there. It's not printing anything. Wonder if I come in here and try to do this. I'm going to put in here 6. See if that does anything. Now this comes back, and I'm going to get the same message. It says immutable value number was never used. Well, it's got to be used here then. So I'm wondering, guard let number equal value. Trying to figure out where we're calling the function multiply by 10. We might have to call that down here. So let's try doing that and see if this works. Multiply by 10, and let's just pass in 6 and see what happens. All right, and it said 60. So let's play computer here. We passed in 6. All right, that became our value right here. So it came in, and that value, which was 6, is less than 10, so we set number equal to that. It didn't print too high in return, but instead it took that number, multiplied it by 10, which gave us 60, and it printed the result. So let's try it again, but this time let's pass in 60, and it should come in here and print out too high and just return when we do that. And it says too high. Now, I'm sure there is a reason that they did this. So in other words, there must be a really good reason for adding this guard statement. And I'll try to take a look at it before the semester starts and see if we can come up with some good reasons. Okay, that's about it for this chapter, though.